Welcome to my video again. Thanks for watching. And in this video, I'm not going to talk about coding, and I'm going to talk about a concept the reason very seems to be very popular, which is the dynamic programming. I would say that uh, dynamic programming is not programming, and this will be the topic today. Well, the first time I heard about dynamic programming was in an interview that Amazon held in Shenzhen many years ago, and they found me from LinkedIn, and I joined the interview there. And some interviewer from Amazon asked me about dynamic programming. They asked, yeah, when I first time heard about this concept, I definitely have no idea what a dynamic programming is. Well, when he asked me in Mandarin 动态编程, well, that reminds me about something uh like JIT. Yeah, JIT is very popular and very well known, but they they don't use the term dynamic programming. You know, another example, that reminds me about dynamic programming is that something like some scripting language that is very flexibly self-extending, like maybe JavaScript. JavaScript is a great extendable language because it can prototype itself and extend an object dynamically, can create object and create class hierarchy dynamically, and according to the you know to data they are processing, or the environment network, or anything else. And WebAssembly, WebAssembly is coming from JavaScript and the web. That's somehow related to dynamic, but that's not dynamic programming neither. Well, another example about dynamic, that reminds me, was that there is some method that create algorithm and generating new code, and dynamically. Yeah, that remind me dynamic about dynamic. I mean, well, today I think AI, it reminds me about dynamic. Because AI is very much, uh, some AIs can, learn from data and trace back, adjust the algorithm, like rewrite the algorithm. That's very, very advanced. That's dynamic. because it learns from the data and change and come out to refine the model, the concept of the model, through neural network, and then turn back to tweak the algorithm itself, and becoming a better algorithm, becoming a better, because in AI there's no need to talk about a programming language, actually, because AI it's more about, it should has its own intermediate layer of a programming language. When we talk about programming, it's more about human and machine interface. Programming, that's what we talk about. If not, there will be an algorithm. Algorithm and dynamic, they are very different. In my mind, that every time when we talk about programming, yeah, that's what that's talking about a programmer. Well, a programmer is human, definitely, right? At least for the day, a programmer, and yeah, he write some kind of algorithm in a language. But an algorithm is more about, mathematics and logic, and the data. It's focused on the data. If an algorithm is not processing data, that's making no sense. That's making no sense. In the past, at least all algorithms are focusing on processing data, sorting, transforming, or storage, yes, or searching. These are algorithms, but these are not programming. Well, the so-called dynamic programming, I remember it so well, because when the first time that guy asked me, a guy from Amazon,
It's 7 hours.
asked me about dynamic programming, the 动态编程. Yeah, the scenes come up from my mind is totally different from what he described to me. He described to me is that there's a maybe I'm not remember that 100%, but it should be like a construct, a data construct, a data structure that could be, and that could be altered by the algorithm itself, and during the further processing, when more data come, and during the processing, it change the data structure, and the data structure affected back to the algorithm. Well, this concept, to me, this concept is actually not new. These are just algorithms. Algorithms are not programming. They confuse. Why I'm talking about this today is just because I found that on the internet it seems to be talked quite many times, and even last night I saw a video. There is a on YouTube. There's a guy talk about an algorithm and saying dynamic programming. Hey, that's confusing. Please stop that. Stop using dynamic programming on a algorithms. No, based on the description from okay, let's see the description from Wikipedia. Dynamic programming is both a mathematical optimization method and a computer programming method. What programming method? Computer programming method? There's no such thing at all. We never see it, such thing, at least for today. If that's the concept, why why are those articles and saying or talk about a algorithm? There's no concrete presentation about a new computer programming method that defines the dynamic programming. The method was developed by Richard Bellman in the 1950s and has found application in numerous fields and from areas engineer and economics. I think they can feel the algorithm and programming. As in both contexts, it refers to simplifying a complicated problem by breaking it down into smaller sub-problems in a recursive manner. Yes, yes. It recursively build for example, there are many like a LGW algorithm that could be classified to LGW compression algorithm that could be I think that could be classified to this thing. Because in compression algorithms like zip or LGW, they actually build a internal dictionary, and each time they process a unit of data, they refine the dictionary. Yeah, the dictionary is very critical for compression. Yeah, for high compression rates. What they do is that it's many derived uh, compression algorithm. They are just refining, to creating a better, the internal dictionary, for the algorithm, and you know, and that's somehow called dynamic, because the further processing is built upon the continually refined dictionary, that's somehow dynamic, but it's not a programming paradigm. That's not a programming paradigm. That's just an algorithm. Continue refine itself. And machine learning, the early machine learning, very similar to this. They construct a model, mathematical logical model from a set of data, and then the algorithm itself yeah, to can classify the data like images, classifying an object in the image and continually learn from from different images of that type, like containing a dog or flowers in the image, and they keep learning, feeding it thousands and hundreds of thousands of flowers images or dog images, and the algorithm can refine the internal additional. That's called that's called dynamic, but that's the algorithm. That's the algorithm. Nothing related to a programming paradigm. So my point is that the programming is confused with algorithm. I believe that when the first time this guy, Richard Bellman, when the first time he talked about this, I believe that he was talking about the algorithm rather than programming. It feels like today dynamic programming has been used a lot, but they are actually talking about algorithms rather than a programming paradigm. Programming is more like a, no. I'm not saying that their research is wrong or these algorithms. These, I'm not saying that this research or these articles are wrong. I'm saying that dynamic programming, the programming term in the word dynamic in this dynamic programming term is confusing with the algorithm. It should be saying blah blah algorithm, maybe dynamic something algorithm, but it is not programming. It's just confusing. It's just confusing. So let's continue with this to learn about this, okay? Well, some decision problems cannot be taken apart this way. Decisions that span several points in time do often break apart recursively. Like, the compression algorithms are actually doing this recursively. They continually get data from the stream and refine the dictionary to generate the better dictionary for compaction such data. And likewise, in computer science, if the problem can be resolved optimally by breaking it into subproblems. Okay, let's see this. And recursive finding the optimal solution to the subproblems. Then it is said to have optimal structure. Let's see. This is actually talking about algorithm, not programming. If the problems can be nested recursively inside larger problems, so the dynamic programming methods, programming methods, this is algorithm are applicable. Then there's a relation between the value of a larger problem and the values of the subproblems. In the optimized literature, this relation is called Bellman Equation. Yeah, very popular, right? I'm not. It's a Bellman Equation. Well, this name seems to be very popular, right? Named after Richard E. Bellman, it is a necessary condition for ultimately rise the value of a decision problem. Okay, let's see. Continue reading. Mathematical optimization in terms of mathematical optimization, dynamic programming. Okay, I won't refer. Oh, this algorithm. I will say this algorithm. Such algorithm usually refers to simplifying a decision by breaking it down. Yeah, by breaking it down into a sequence of decision steps over time. This is done by defining a sequence of value, taking one as an argument representing the state. Yeah, this is the state. The state was what I was talking about. The dictionary, the internet dictionary. They continually refine the state, internet state. The state variable is one, or a set of state variables. Yeah, they what it say is that use in this article it says that refers to simplifying a decision by breaking it down. That's what I say. Refining the dictionary, the internet dictionary. That dictionary is actually the state variable in this article. Like, let's see, a state variable is one of the sets of variables, right, that are used to describe the mathematical state of a dynamical system. Intuitively, the state of a system describes enough about the system to determine its future behavior. In the absence of any external frequency attempting, yes, that's exactly what I'm talking about. Those are algorithms. It's a set of algorithms could be referring to this so-called dynamic programming. It's not programming, it's algorithms. I believe that if you check the LZW, LZW algorithms, that's that could be classified to this and even zip, because zip in the internal inflation, freight inflate. Yeah, it's widely used on the web for compression. Inflate public in the public domain. The internal state they actually have such a concept of what it says a state variable, right, of the system at times I from 1 to n. The definition of each value obtained in state y at can be found, yeah. can be found by working backwards. Okay, let's read it again. The values vi at early times of this set can be found by working backwards, which means it could be reversible, I think. Yeah, the state could be reversible. This is actually exactly the same as compression. When LCW is compressing the data, it builds the dictionary from data and refines the data, continually refines the data recursively. Yeah, recursively. And when decompressing, it needs to use the dictionary to to uncompress to decompress the original data. That is what it says. Values of vi at early times can be found by working backwards. Exactly the same thing. Working backwards. And LZW is not the only algorithm doing this. And I think in signal processing, algorithm, digital signal processing algorithm, there's a lot of such concepts that's so-called dynamic, but digital signal processing using general purpose processor, DSP, right? Signal processing algorithm. Okay, let's continue with this. Using a recursive relation called Bellman Equation. Bellman Equation. Because I heard this a lot. I heard this Bellman Equation a lot. Seems to be used in math for this set of values. The running state y is calculated from vi by maximizing a simple function. Usually the sum. Yeah, the function, such function, in some scenery or in some cases or scenery, they use the term kernel terms. They use kernels by maximizing a simple function. Yeah, such a simple function, kernel, in AI or computer graphics. At least in AI and computer graphics, the term kernel was used to refer to an algorithm that could be used for very critical, very critical kernel. Yeah, the kernel, critical parts of the algorithm. For example, a image processing algorithm, there was a critical path being calculated recursively from time to time. That's the kernel. And in AI, there's a kernel maybe calculated by each neuron. That's the kernel. Each neuron is calculating such algorithm, and it's a simple algorithm. Like you said, a simple algorithm. Usually, the sum of the gain from a decision at a time. Well, comparing to image processing kernel algorithms, it comes up a data to refine the data, and the data could be used again for the algorithm. That's somehow different. I think at the time 1 minus I minus 1 and the function vi at the new state of the system. Yeah, and the function vi comes up a new state at I minus 1 and the function. Because the function, the kernel function is heavily depending on the data. So in this statement, it says it traces a new function vi at the new state, right? At the new state, a new function is that. Actually, it changed the algorithm or just the state. When it's changing only the state, it should not be calling a new function. But anyway, in the article, in the concept, if it's making a concept, they could say it anyway. But it's hard to find such thing, the algorithm learn from data itself and change the algorithm, not the state. Change the algorithm dynamically and use a new function, use the new algorithm. That's the function. In this case, the vi, and you use it back to the system. I think the only thing I heard might be the AI. The compression algorithms are just refining the data structures, the states. They're not refining the algorithm itself. They're not changing the algorithm itself. Such dynamic system is hard to be found in existence. At least there's no, maybe some labs of big companies, they may be studying this thing, but there's no such thing on the internet. I mean, a product. There's no such product on the internet yet. If you know anything about this, please tell me. I will be highly appreciate. Since vi has already been calculated for the needed states, the above operation used for those states. In this concept, new function use new state, and finally v1 at the initial state of the system is the value of the optimal solution. Finding basically it refines the state, it continually changes the state based on the algorithm, and to come up the optimal solution. The optimal values of the decision variable can be recovered one by one. Yeah, that's exactly the same as compression. Compression needs to be, compression has many kinds. Some may cause data loss. Some, at least two kinds. At least two kinds of compressions. Data loss, and the other kind not data loss. Like zip. Zip is not data losing compression algorithm. But like JPEG, like video compressing, they are data losing, because once an image is compressed using JPEG or MPEG, they can never be recovered to the original. They cause this data losing. So this is the two kinds. The optimal value decision can be recovered. So in this case, the JPEG and MPEG or any kinds of video compressing algorithm, they are not classified in this case by checking back the calculation already performed. By checking back the dictionary, the internal state variables, the set of state variables. So this is what I do. It is an algorithm. It is not programming. Programming is more about a programming paradigm. A paradigm is more like it's not a model. It's not a style. A paradigm is it's similar to a concept. It's similar to a style, but it's like a new way, it's involving algorithm too, but paradigm is not algorithm, it's not style, it's not module, it's not a module, paradigm is new thing, just being used to describe a different way, different, like a programming, like in programming languages, like libs, like functional programming, like object-oriented, like procedure-based programming, like assembly. These are programming paradigms. So these are programming. So please do not confusing it with algorithms. And this described here, mathematical optimization process. These are algorithms. These are not programming. Okay. Control theory. In control theory, a typical problem is to find an admissible control U star, which causes the system to follow an admissible. Okay, let me see what does it mean. Admissible. This is admissible. Okay, this is very high abstraction. On a continuous time interval that minimize the cost function. Oh, this is the cost function. This is the cost function. Very complex. The solution to this problem is an optimal control law, a policy, which produces an optimal cost to go function. The latter obeys the fundamental equation of dynamic programming. Okay, I hate this referring. I hate this referring because it's confusing. Dynamic programming is confusing. Minor what? Minor what? A partial differential equation known as the HAB equation, in which one finds the minimizing u in terms of t, x, and the unknown j1, and then substitute the result into SJB equation. Let's see. In optimal control theory. In optimal control theory gives the necessary and sufficient condition for optimal control with respect to loss function. A loss function or cost function is a function that maps an event or values of one or more variables into a real number, intuitively representing some cost associated with the event, and optimization problem seeks to minimize a loss function objective. Okay. JB. The equation is the result of the theory of dynamic programming, which was pioneered in 1950s by Richard Bellman. Richard Bellman was an American mathematics. Bellman. Yeah, I'm not sure. I heard a lot about a name, Bellman, in many videos. I'm not sure if they're referring to this guy, Bellman等式. That seems to be very popular. I'm not sure if they are referring to this guy, Richard Bellman, 理查德贝曼 and co-workers. The connection to from classical physics was first drawn by the corresponding difference equation is usually referred to as the Bellman equation. Optimal control. Okay, I'm not going further in this video with this. Maybe I'll study this later on, but I'm not in this video. So in computer programming, there are two key attributes that the problem must have in order for such algorithm to be applicable. Optimal structure. Yeah, optimal structure is in this case, I think it's the algorithm must be able to recursively from a start state and process and could be must have an equation to be calculated into a goal, right? Into a goal state, into a target state, into a goal. And that calculation and that path could be saved. Like this is the state set, this is the state set, this is it. In some cases they call it kernel. I think that should be similar, very similar to, at least to me in concept, they are very similar in kernel state, calculated from start, like apply to a goal in this and recursively calculated and the states grow and the states more and more states that added or refined to the state variable, and the system become better and better. This somehow very similar to the machine learning. I think the theory of machine learning may be coming from this. I don't know. Just my guess. Yeah. Start applying 5 and get to a state, and applying 20 to a goal. Applying 2 get to an intermediate state, and applying 25 get to the goal. When applying 11, it gets to the intermediate state, and applying 17, it get to the go to. So in many problems, we can find different solutions. This one part is one solution. When we find different solution, and one solution is actually reflecting one state. That state is stable. So in many complex complicated problems have such properties, attribute. Yeah, they find the algorithm finds the problem, a different path to solve the problem and get to the goal. Once they found the path, it comes with the state, a new state, and being recorded, being memorized by the program. That's what I said. The dictionary used in many algorithms. That's very similar. They just find the ways, find the path, find the solution, and the new state comes up and put it back to the dictionary or to the kernel, to the state variable, and the system becoming better, This is what I think. This is what it said. That the problem must have in order, must be optimal structure. It's like this. Optimal structure is like this, which is like you can start from one stage and find a variable. When applying that variable using an equation or function, using an equation, and get to an intermediate state, and get to maybe many different intermediate states, and at the end get to the goal. And that path become very important, experience, very important experience to the system. And the system records it records it. When it's growing, the system, the entire system become better and better. This is somehow learning, self-learning. Yeah, self-learning. I think the concept is coming from this or related to this. Yeah, it is related, but coming from this, I'm not sure. An overlapping subproblems. Yes, the overlapping subproblems. Overlapping subproblem is like you can find different paths, different ways to solve the problem. Maybe this is my explanation or understanding to this concept, overlapping subproblems. If a problem can be solved by combining optimal solution to non-aware, the strategy is called divide and conquer instead. Divide and conquer instead. Divide and conquer is an algorithm design paradigm. This is why merge sort and quick sort are not classified as dynamic programming. Okay. Merge sort and quick sort are not divide and conquered. Okay. I will study in future for more, but not in this but not studying everything in this video. Okay. So well my point is just that this so-called dynamic programming is just an algorithm. It's not what we said. A programming paradigm is very different. Yeah, this algorithm it involve reminds me many similar cases in the algorithm, like many compression algorithms, like in the AI, like in computer graphics. In computer graphics, like image recognition algorithms. There are many cases could be classified to this. But what confused me is the term is confusing with the programming language in programming language with the programming paradigm. This is very confusing. So I may say it's bad. Yeah, it's confusing. Okay, well, that's my point, and I will keep learning and learning about all these things. Yeah, this is very interesting and maybe hard, but I will keep learning. Well, my point is that the term dynamic programming is confusing with the programming paradigm like functional programming, object-oriented programming, and procedure programming, and anything else. Anything else? Dynamic programming, maybe when someday such a programming language is designed, then we can use the term dynamic programming because we can write such a language that could change itself dynamically. I mean, well, it's possible. In theory, it's possible. Maybe in the future, especially when AI is well developed and developed fast today, it's possible to have a programming language that could learn from the nature, that could learn from the nature, and then refine the language itself, yes, the programming language itself, and then give us a better programming language. I think that's what we may call a dynamic programming language. So this is why I said it's confusing. Maybe in theory, they are moving forward that direction. I'm not sure. If they are moving towards that direction, that would be incredibly insane. A programming paradigm that could be always learning like AI learning from the nature, from any input, from data, from nature, from images, from text, or from anything else. You put to it, and then it refines itself. It refines the programming language and generating a new programming language, a better programming language for humans. The problem is human. How could it be defined as better? How it could be defined as better programming language for human? Well, AI itself, they're simple. They I mean, when they are making the decision, they might be simple. They are just depending on a equation. And if the equation gives it a better way, give it a higher rate, then it pass. Yeah, it got the decision. The decision passed the test. But how do you define a better language? How do you define a better programming language to human? Because to human, there's it's very difficult to define better language to human, which I think uh, based on this, you have to find the equation to define a better find the equation like Bellman equation. A Bellman equation. You have to find the bed the equation to define, to define what is a better programming language. Let's what is the better programming way approach or any terms, yeah, to define what is better programming approach for human. You need finding the better equation to define what is the better programming approach, and then use it back to the programming. I mean, if such a compiler exists, such a programming language exists, then we can use dynamic programming Yeah, we can refer it to dynamic programming. So so that's the point. That's the point. That's the point. Well, okay, that's all for this video. If you like it, please comment, or any idea, please comment. I am happy to see your comment. Okay?